Hello and welcome to Slooh, a worldwide community learning to explore space together and control Slooh's online robotic telescopes at our flagship observatory in the Canary Islands, which is what you're seeing there, and our Southern Hemisphere observatory in Chile. More about those later when we watch our live feeds. Now, I'm Paul Cox, one of your hosts tonight, and you're joining us for a spectacular event, a super blood wolf moon lunar eclipse. And this one is really special. And to help explain why it's so special, please welcome my co-host up there for tonight, Slooh's Director of Research and Education, Dr. Paige Godfrey Page. Are you as excited as I am about this tonight?
I am. I'm very excited about this. And I'll start off by saying it's so special to me, at least, because this one is actually visible from North America and many other places as well. But I am located in North America and I've never seen one live before. And despite I'm on the East Coast, despite the huge winter storm that we were supposed to get, we actually have very clear skies here. So I'm really looking
Excellent.
forward to, yeah, being able to step
Oh,
outside.
wow,
I
that is
might
going
bring
to be
my
so cool.
laptop with
And I
me.
know I know the folks at Slooh HQ have had 4 inches of snow
Hmm.
there tonight.
Yeah.
So a lot of people in the US have had this snow. Now,
Yeah.
what's going to happen a little bit later is you are going to be in for such a treat because when the moon turns a rusty red or a peach color, that's going to actually reflect on all of that white snow. It is going to look utterly spectacular. But anyway, Paige, I mentioned that this total lunar eclipse is special, but why is this particular eclipse a not to be missed event?
Yeah, so this one in particular is not to be missed because the next one is not going to be until May of 2021. So a little over 2 years from now. And it's the last one visible from the United States until the following year in May of 2022. So depending on where you are is depending on how much longer you're going to have to wait. But we were spoiled that we just had a total lunar eclipse last year. We actually in the summer. And so now we have we're graced with this one, but then you're going to have to wait over 2 more years for the next one. So if you miss it tonight, I'm sorry.
And Paige, that is even worse for us Europeans because actually it's going to be another couple of years after that before we can see it. So,
Mm,
this is a global event tonight. Everybody on one half of the earth can see it.
yes.
In the UK and Europe, we're seeing it
Hmm.
kind of, the moon's already overhead. It's 3:30 a.m. here. So we're going to see the total phase of the eclipse when the moon's quite low. But in the Americas, you'll be seeing the total phase of the eclipse when it's virtually overhead, aren't
Yeah. So we have here in the visibility map you can see on the screen. We have it's visible in all of North America, South America, and a little bit of Europe and Africa, all the way out past Alaska. So there's a really large viewing area, and it's not necessarily unique about it. It's just where the nighttime part of the Earth is during this phenomenon. So there's always going to be part of the Earth that's in nighttime when the lunar eclipse happens, and so it's just so happening that we get to see it this time. So this
it? Exactly.
visibility map is great. It also shows you the different um, parts that can see a full eclipse versus a partial eclipse.
Yeah, this is going to be such a great event. So, what are we going to learn about during this show, Paige? What have we got lined up?
So during the show, we're going to talk about what a lunar eclipse is compared to a solar eclipse. We also have Helen Avery coming on a little bit to talk to us about the name, the wolf moon. So you mentioned this
Yeah,
is a super blood moon, it's a wolf moon, and then about some Mesopotamian traditions that have to do with this. And then that have to do with this. And then we also have a special guest coming on a little bit later that I'm going to interview. We've had her on before. Her name is Raquel Nuno. She's from UCLA. She's a planetary scientist there, and we're going to have some conversation about the far side of the moon and the Chinese lander that just landed there yet for the first time ever. Um, we also are going to talk a little bit about what to look for outside, what you can expect to see. And if you have any questions for us throughout the night, we'll honor those as well. So we're monitoring all of our feeds: Facebook, Twitter, Slooh.com, YouTube, Twitch. So everywhere we're streaming, you can ask us questions. I think my video is unfrozen now. I'm just going to say that. I totally did freeze, but I think we fixed it. So thanks to the studio for the suggestion to flip my camera on and off. We're good. Back.
Yeah, Paige is not usually quite that frozen, but anyway, glad to have you back.
Still like that.
Glad to have you back, Paige. So the best place for people to ask questions is over on the Slooh discussion boards
Yeah.
at slooh.com. And don't forget, viewers, if you are watching, we're about to see our live feed, but if you are watching at slooh.com, underneath the video of the show, you can flick little tabs, and those are all the live telescope views that we've got lined up. And you can hit the camera button, and you can snap your own images from those feeds. So, Paige, I guess we should probably take a look, shouldn't we, at some of our live feeds. We'll start off with the
Okay.
observatory Pico del Teide cam, which is so this is at our Canary Islands Observatory, which is about 300 miles off the west coast of Africa. Now, this is a bit of a weird view at night. We're kind of looking down. There's cameras at 10,000 feet altitude on top of the volcano. We're looking down onto the ridge, which is just on the left there, um, where the flagship observatory is at the Institute of Astrophysics of the Canary Islands. And we've had this cloud kind of bubbling up over the observatory, but it's kind of dropped down a little bit low, and we could just see it move there. So we're crossing things that stays at bay. But let's take a look at our observatory panorama, because this is a great view, I always think, Paige. So in this, excuse me, it looks like daylight, doesn't it? But in fact, that's because we're under a full moon tonight, obviously, because it's a lunar eclipse, and it's lit up the entire observatory site. So we can see there that the clouds are remaining low. But without further ado, Paige, how about we look at our Canary 1.5 meter telescope live stream tonight?
The best. There
What
it
are we
is.
seeing
If you
there,
wanted
Paige?
to know, yeah. I mean, we're looking at it
So,
right now.
so we're in the penumbral phase, aren't we? So we're going to talk about the different phases of a lunar eclipse, during the show. So, but that's already started. So we've got a countdown there. We've got an hour and 3 minutes or something like that until we enter the total phase, which lasts 62 minutes tonight. But what are we seeing here then? We've got a very distinct chunk taken out of the moon there.
Yeah, this is the shadow. This is the penumbral shadow starting. So, total lunar eclipse happens when the Earth is moving through in between the moon and the sun. So we have the sun is in the center of the solar system, and the Earth orbits the sun, and then the moon orbits the Earth. And on occasion, the moon will go completely behind the Earth in its shadow. And so that's what's happening tonight. What we're starting to see right now is the moon moving into the Earth's shadow, and the first part of the shadow is called the penumbral phase. So that's where that word is coming from. And so we're seeing Earth's shadow on the moon in that bottom left-hand corner. And I just want to make note that if you are watching, you should go to slooh.com. You can take pictures as we go through the feeds tonight. So either you can get to it either straight from our telescope pages, or if you're watching on slooh.com, underneath of the show, you can click through the different feeds that we have up, and you can take images right from there. So if you take images throughout the evening, you'll be able to make a beautiful animation of the full eclipse.
Exactly, and that's always something that I absolutely love doing as well. So we are going to talk about a lot of this later on as well. But the total eclipse, the partial phase, so this penumbral phase lasts tonight, I think, 3 hours 17 minutes. But in the middle of that, we have got the total phase. So let's take a look at our other feeds. We've got our Canary 2 wide field view. Have a look at that. Right now, this one's an interesting one, Paige, because this telescope is usually too sensitive to be able to image a full moon because of what you can see on the right-hand side there. It's overexposed.
Right.
But where the penumbral shadow is coming in, we're seeing quite clearly that it's getting dark enough for that telescope to take as well. We've also got our Canary 2 ultra wide field view tonight. So we've got so many telescopes pointed at the moon tonight. Oh, that is wonderful. Now, this is one of Slooh's smallest telescopes, but actually for the moon, it's one of the best because it gives us this kind of contextual view. Now, viewers need to keep a really close eye open in this view. And in fact, when they're looking at the lunar eclipse in their own backyard, because When it's in its total phase, we may start seeing stars appearing in the background. Now, I might have to make some adjustments actually to the telescopes and the exposure times and stuff like that from the CCD cameras because it may get too dark, and we can see there it's already getting too dark. So we're going to have to make these small changes. Now, let's just take a look at our next telescope, which it's our Canary 3 telescope. Now then,
Mhm.
look at that. So this one is grossly overexposed, but this is the one that's going to give us our color views because this uses a special color CCD camera, and this is going to come into its own during that total phase. So in an hour's time, this is the one that's going to show us the beautiful peachy. I always think it's peachy, but different people say it's kind of different colors. So keep an eye on this one. It doesn't look round at the moment, but that's just because it's overexposed. But we've also, Paige, got some close-up views as well because we've got our Canary 4 solar system telescope. Now, this is really zoomed in. You can see how much this is zoomed in, but already we're seeing that penumbral shadow, first penumbral shadow eating in to the bottom left-hand side. Now, we have also got our Chile observatory online tonight. Let's have a quick look at the all-sky camera from Chile, if we can, because we have got some clouds there.
Yeah.
So keep an eye on this one. You know, we're going to keep the observatory open because it's surprising how much you can image the moon through even light clouds. So not providing great views at the moment out of Chile 1 telescope, but we are going to keep open. And in fact, let's take a skip back because I do want to point out people can also take snaps of the Canary All Sky camera. Now, this one page is going to make a fascinating time lapse, I think, tonight because what we're going to see is that whole landscape, the sky, darken. So, unfortunately, we've got a bit of condensation on the lens of this one, but we're going to see this dark, and we may start seeing some color coming through on this one as well. And you can see the white domes there on the left-hand side. We may even start seeing some colored reflection of the moon there. So those are all our live feeds. And in fact, we've got a couple of other special ones as well, haven't we? We've got Florida. We've got Stephen
Yeah.
Amman, who's
Yeah.
long time Slooh member. And Stephen has been, he's got a little bit of cloud there tonight, but this is a live video stream that Stephen's providing for us tonight. So thank you very much, Steve. Great job. Because, as a lot of the USA is kind of clouded out. But here we can see very distinctly, that chunk of the moon being taken out. Now, Stephen, just like anybody else photographing the eclipse tonight, is going to have to change their exposure time as the moon darkens, because you can see there it's going a bit black. And we're not going to see any colour until the start of the total eclipse. But Paige, that's how. Actually, have we got Arizona up as well? Let's see if we got Arizona. We got a special feed from long time sleuth partner Matt Francis down at the Prescott Observatory in Arizona, and he has got some clouds down there, but they have cleared enough for him to be able to open his observatory, and he's setting up his feed. So we might not be ready for that yet, but the studio will feed that in while
Yeah.
we're discussing. So we'll jump on that if we say. But Paige, we said at the top of the show, we said it's a super moon, we've said it's a wolf moon, we've said it a blood moon. Let's deal with the first of those.
Okay.
What on earth is a super moon?
Yeah. So here's a great comparison of a supermoon on, if you're looking at the monitor on your right hand side. Let me put my pen down. Sorry, I tend to work. I like talk with a pen in my hand, like a teacher. Um, so we have supermoon is obviously the larger one, and then a mini moon is a smaller one. And so what's going on here is when the moon is full and it's at its closest approach to Earth, we call it a supermoon. And then when the moon is full and at its furthest approach from Earth, we call it a mini moon. So the orbit of the moon around the Earth is elliptical. It's not a perfect circle. So it does come closer and further to and from the Earth. And so right now it is at its closest approach. So we call it a supermoon. But if people were watching our lunar eclipse prep on Friday, they might remember that, Paul, you have some strong feelings about what we call a supermoon, versus
I
just a normal close approach. So, do you want to explain that a little bit?
Yeah, shall I just get my soapbox out and climb on top of it? Because people reading up about this eclipse is may have read that this is the first of three supermoons. So we got one in January, one in February, one in March. Now that's because this definition is that it's within uh, 90% of its perigee, closest to perigee, which is this other word for it being so close to us, around either a full or new moon. But I kind of cannot get out of my head what's super about something that happens 3 months in a row. So actually, I think tonight is the one that we should be celebrating. And the reason
Right.
why that is because tonight's supermoon is the largest of 2019. So I think we should be changing that definition just to say a supermoon is the largest full moon of the year, of the calendar year. This is another little example that I did because a lot of
Hmm.
people will say, oh yeah, I can easily spot it in the sky. But don't forget, when you see a super, the last time you saw a full moon was a month ago. So you've really got nothing to compare it to. It's very easy in these images where you see both of them together. And it's
Right.
what? It's about a maximum of 15 or 16% between a mini moon and a supermoon in their size. But there is one thing that I think I can spot the difference on, and it's not the size, but you're great at the math. This 15% size difference in angular size actually equates to the moon, a supermoon, being 30% brighter than the
Right.
mini or micromoon. So there is, I saw, we were chatting earlier in our little chat system, and you looked outside when the moon came out, and you just came back, it was all caps, and it was, wow, the moon was absolutely astounding. And I'm not sure whether or not it's because we're expecting it to be better than normal, but I'm pretty sure I can tell that there's something a little bit special about a supermoon. I mean, what was your impression tonight when you saw it outside?
It was incredible. So I was in the car driving when I saw it for the first time tonight, and I posted on Instagram. Actually, my niece took a picture of it from her iPad through the van window, so it's totally like it's blurry because we're moving, but it's fine. It looks like the sun. Like it was
Uh,
so big and bright and white. I looked at it and I was like, that I mean, that's not the sun, but like, oh my goodness, it was
yeah.
huge and it was really, really unbelievable. It is 30% brighter. And I forget what the math is. I wish maybe I'll look it up on a break. There's some comparison of the supermoon to the mini moon in pizza size. Like
Oh,
how
is that?
many
Oh, that would
bigger
be good.
inches, yeah, the pizza would be. Um, but
Oh, well,
yeah, so
I'd like to hear about that later. So maybe in a
yeah,
break you
look
can
it
you
up.
can look
Yeah.
that pizza reference up. But
Yeah.
just to tell people a few figures tonight. We're looking at full moon tonight is 357,000 kilometers. That's 222,000 miles. Close, because that's why it's a supermoon. It is at its closest to Earth. Um, but it can get, about 30,000 miles further away, can't it, Paige? So this difference is not very much actually in distance. But this is also because of its elliptical orbit. So the moon's orbit around Earth is not a perfect circle, is it?
Right. So when it's closest to Earth, it's called the perigee. And
Mm.
when it's furthest, it's called apogee. And like you said, the average distance of the moon to the Earth is about 200 and like 38,900 miles. So like 240,000 miles. And at perigee, at its closest approach, so the supermoon that we have tonight, it's at about 220,000, 221,000 miles. And then at the apogee, which is the farthest point, it's at about 253,000. So it
Okay.
does vary about 30,000 in total, so about 15,000 on either side of the mean distance, um, because it is an elliptical orbit. And something else interesting about the orbit, which we can talk about a little bit later on the show, is that the orbit around the Earth is tilted by about 5 degrees from the ecliptic. So,
Yeah.
um, this is hint hint why we don't have eclipses every single month. Which we'll go into a little bit of detail later. But yeah, so the moon is also tilted on its elliptical orbit.
Yeah, so it's all part of this fascinating geometry, which
Mm,
is ultimately the cause for both solar and lunar eclipses, plus a whole stack of other phenomena that we spoke about in our show
mhm.
the other day. But let's check in back on the live feed. Oh, look at this. We are losing the moon very, very quickly. So,
Yes.
what I'm going to have to do, Paige, at the top of the hour, when we finish this segment, is actually change all of the settings at the observatory to make sure that we don't lose it entirely. So, this is great. We've never actually used all of the Canary Islands telescopes for a lunar eclipse before. And don't forget, viewers, if you've come in kind of late, all but our Canary 3 telescope from the Canary Islands will be in grayscale. This is the one that is going to come into its own in 49 minutes time. You can see it there, the countdown, the total eclipse. So when the moon gets dark and not overexposed, in fact, oh, look at that. That that was good timing, wasn't it? We can already start
Yeah,
to
you
see
can see the
some
detail.
color on this. So this is going to be a really interesting feed to keep an eye on. But also keep an eye on our live video feeds from both
Mhm.
Florida. We've got long-time Slooh member Stephen Amand. And Stephen, by the way, keep your eyes open for Stephen's post in the Slooh discussion. Because if there's ever any kind of astronomical event going on, Stephen always posts this great information about it, all the timings, where you can see it, what to look and stuff like that. We should really get Stephen on the Slooh team, I think. But we're also waiting for our Arizona feed to come online as well. So we are going to keep an eye on that. But Paige, so there's supermoon. We can talk about that a bit later. But
Mhm.
our next bit of our super wolf blood moon is the
Yep.
wolf moon. Where does that name come from? I know Helen Avery is going to be talking about this in more detail later, but just
Yes.
to give viewers a bit of a spoiler
Yeah.
alert on this one.
Yeah, so I will definitely let Helen take the expert part on it. But so the wolf moon, every full moon of each month is named. And the name comes all the way back from the Native Americans. They would use the full moon sort of as a calendar. And so, for example, there's the strawberry moon in June and the harvest moon in September, October, September, one of them. But
September, yeah, September.
September, thank you. I was like, "Paul, help." Yeah, one of them. Yeah, and the wolf moon in January. And so then what the second full if a second full moon occurs in a month, it's called the blue moon. But the first names of the full moon every month is from the Native American time, and it typically represents something that was happening in their calendar. So one of my favorites is the strawberry moon, and it was just because June was a really great time to harvest the strawberries. And so it was the strawberry moon. It's not because the moon is pink. It's because the original ancient astronomers saw it and just used it as a calendar for themselves. But actually, the wolf moon, I think there's some discrepancy on whether it's named from the Native Americans or from the Anglo Saxons. And I'm not entirely sure the whole story on it. And so I think we should let Helen give us her insight a little bit into the name,
Exactly.
which is coming up. Yeah.
Let's defer to Helen on the detail there, but there are so many calendars still in use around the world,
Yeah.
which are lunar calendars. They're
Mhm.
based. I mean, we've got obviously the most important one, probably the Islamic calendar, is sparked off the beginning of each month, is generated by the new moon, the sighting of the new moon. But Hindu as well, that's still a lunar calendar. And of course, as you say, the Native Americans were marking. I love this more than any other, actually, that they marked it with something to do with their environment. So I kind of like that one best of all. So there's Wolf Moon. Helen's going to be talking about that a little bit later
Mhm.
on. So the last one that we need to explain is the blood moon.
Blood
Why
moon.
is this so commonly referred to as a blood moon?
Yeah. So if we bring back up Canary 3, our color feed for the night, the one that we're referring to the most about color. So you can see, thank you, studio. You can see in the top left corner where the shadow is starting to overtake the overexposure of the rest of the moon from the telescope feed. You can see it's starting to turn red. Look at that beautiful color. Again, the live feed updated right in time for our words.
Exactly.
I swear that's a coincidence, everybody. The red color is coming through, and this is why it's called the blood moon. And we'll go into a little bit deeper dive on the science behind it in our next segment. But basically, what's happening is the light that we see from the moon on any normal night, the moonlight is reflected light from the sun. So the same thing is happening here, except that because the Earth is in the way, the sunlight is going through the Earth's atmosphere first, then hitting the moon, and then reflecting back to us. So as the light goes through the atmosphere of the Earth, it's basically being scattered away, and we're seeing red light coming through more. And so again, we'll go into a little bit more of the physics coming up, but that's what's happening. It's because the light is being bent through the Earth's atmosphere before it's reflected off the moon's surface. So we see this red color. We call it the blood moon.
And
Red
don't get worried,
peach.
anybody out there. Paige said we're going to get into the physics of it. We've actually got some great graphics as well for people like me, because I need a diagram for that kind of stuff.
Physics is probably, I'm trying to like normalize physics and math. Like they're not that scary. It's all good.
Well, that's scary to some of us,
Yeah,
including me.
it's
But
okay.
this,
We'll make them attainable.
exactly, this is going to be a terrific feat to be snapping
Yes.
images of. So if you are watching the show on an embedded website or anywhere else, if you do watch it over at slooh.com, you'll go to the Situation Room, watch the show live there. You'll see our video that we're watching now, but underneath that, you'll see different tabs, and those different tabs each of the telescope feeds that we've got tonight. And you can click on those anytime to see the live image stream from that particular telescope. You can hit the snap button, the little camera icon, and it will snap your own image. Now, you have to be registered on the website, but
Yep.
registration is free if you want to sign up as Slooh crew. But if you want to control all of these telescopes that we're looking at these live feeds for, and I can't take my eyes off this one, it's great. If you want to control these very telescopes, both at the Canary Islands Observatory and our Southern Hemisphere Chile Observatory, then you can sign up for a Slooh Apprentice or a Slooh Astronomer membership. And I'll tell you, it's a lot easier than you think, and the community is always there to help, as am I and a few other people. Anyway, Paige, we've talked about where people can view the eclipse. Actually, let's just go
Mhm.
back to that, because let's just put another a little bit more detail on that. So let's go back to our visibility map. So I'm in Europe, and the moon, as we can see here, we are entered the total phase. Greatest eclipse is going to be in. Well, actually, let's have a look at the timings, because I think I've got those slightly wrong. So total eclipse starting, yeah, in 42
At
minutes. So
Yep, 11:41 Eastern. So it's 0441 UTC.
what we can see
Yeah.
here on the map is basically, uh, unlike a solar, you have to be along the path of totality, which is only about 70 to 100 miles wide, in a particular location on Earth at a particular moment in time, because it's just a small dot shadow crossing Earth's surface. But for a lunar eclipse, over half of the Earth can see a lunar eclipse. So basically, if the lunar eclipse is occurring when it's nighttime where you are going to be able to see it. So what you can see here is our poor Slooh members down in New Zealand and Australia can't see
Mhm.
any of the lunar eclipse because they're actually in daylight at the moment. You can see there most of China, and West Asia and India, so East Asia, also can see. You can then see coming over Africa and then Western Europe, we're seeing it as the moon starts to set. So some people, probably, yeah, probably further east at the moment, will actually not no longer be able to see the moon. It will have set. For people in Hawaii, the moon is just rising right over there on the left. But for you, Paige, you're in this ideal position. You're in this total white zone. So what does that mean for people in North America and South America? Right.
We get to see the full total eclipse. So we get to see all the phases, the penumbral phases, the umbral phase, and then we're going to go right into the greatest eclipse moment, which is at for us in the northeast of the United States. That is going to be at 12:12 a.m.
And
05:12 UTC.
and that's almost perfect because that's obviously around midnight, which means the
Yeah.
moon's going to be virtually directly
Yes.
overhead. So the
Yes.
folks over there at on the East Coast at Slooh HQ, they've had some snow
Mhm.
today. I said this at the top of the show. If you are lucky enough, and we don't say this very often, but if you are lucky enough to have had snow today and you've got clear skies to see this eclipse, I've never seen this. So I'd like to see some people maybe share some photos of this with us. I
Yeah.
believe that that snow, instead of being moonlit white like it normally is, I believe that snow is going to turn orange and not through a bad way. So I
It
think that's going to
should.
be absolutely fascinating to see if that happens.
Oh, I caught that reference in there. So some puppies
Listen,
running
Paige,
around and some raccoons.
Paige, is there anything else we should do before we just take a short break and come back and do maybe a little bit more?
Yeah. Yes. Well, just real quick, what we have coming up for the rest of the night. Paul and I are going to hop off for a few minutes. We've got some segments from Helen. She's going to give you some information about the name, the Wolf Moon, where it came from, how ancients saw the lunar eclipse, and how they reflected upon seeing Earth's shadow, and also about seismic activity if that increases during an event like this. And again about the wolf moon, and the wolf man creation story, a poem about the wolf moon. So that's going to be really exciting. So she's got those segments for us, and then Paul and I will come back on again after. We're going to go through some fun, I won't use the word physics, science, about the color of the blood moon, the phases, why we don't see an eclipse every month, and then a couple fun ones too. So stick around. We're going to talk about what it would look like if you saw this from the moon instead of from Earth, or and also if the Earth is flat, why do we see the lunar eclipse the way we see it? So we're gonna go that far tonight. We're gonna take it to that point.
Exactly.
And
So
then yeah,
if any viewers out there know any flat earthers, make sure that you get them to tune into the show
yeah,
because we're
yeah.
going to catch them up with about 2,000
Mhm.
years of science history about
Here to debunk.
basically, unfortunately, folks, spoiler alert, but you're wrong. But Paige, we've got a really special segment coming up a little bit later, haven't we? After
We
we've
do.
done that little bit of science and stuff.
Yes, I'm really excited. We are having a special guest tonight. Her name is Raquel Nuno. She's a planetary scientist from University of California, Los Angeles. And we've had her on before, just in this fall. And we're really excited to have her back. She's fabulous. She does research on the surface evolution of the moon and Mars. And so she's excited to talk to us about what lunar eclipse means for her. And we're going to go into a little bit about the far side of the moon and the Chinese lander that just made the first touchdown ever on the far side of the moon. So, really looking forward to seeing her insight there. And we'll also, her and I will be on for the greatest eclipse moment at 12:12 a.m. Eastern time. So, stay tuned for that. That'll be when you can really see the full impact of this.
Yeah, that's when all the colours that we see should get
Mm,
their deepest because it's when the moment of greatest eclipse is when the moon is in the heart of that
mm.
dark umbral shadow. So yeah, we're looking forward to that. So listen, there's loads to look forward to. Make sure that you carry on watching during these breaks, and don't forget if you're watching
Yeah.
Slooh.com, you can switch through all of the telescope feeds and be snapping those images so that you capture the entire story of this lunar eclipse as it
I'm
unfolds. But
snapping my images too.
jolly good. Go for it, Paige. Looking forward to seeing a time lapse tomorrow. That's if we're awake tomorrow, of course. But anyway, listen, don't go anywhere. We will be right back after this short. In fact, Helen's going to be back right
Yeah.
after this short break, telling us about how the ancients saw lunar eclipses
Yeah.
and also more about the moon. So we'll be back in about 20 minutes' time. Bye for now.
We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now. Give the gift of the universe. Give the gift of Slooh. A celebration of every magical moment in the night sky. For just $60, you can give the budding space explorer in your life the gift of a full year of Slooh membership. It's available now at slooh.com.
Hello and welcome back. You're here with us live on Slooh as we watch the 2019 Lunar Eclipse, and I am Helen Avery. So it's a special one. It's a wolf moon, it's a lunar eclipse. We're not having another lunar eclipse until 2021. What more do we need to say? But I'm here to just share a few other reasons why a lunar eclipse is so special. So we talked about this before on Slooh, but to ancient peoples, a lunar eclipse wasn't special so much as terrifying. The ancient Mesopotamians, for example, saw lunar eclipses as an assault on the moon, and the assailants were 7 demons. Now, traditional cultures like the Mesopotamians linked whatever was happening in the sky to circumstances on Earth. And because the king represented the land in Mesopotamian culture, the people viewed a lunar eclipse as an attack on their king. So what happened was, in anticipation of lunar eclipses, and it's kind of amazing to think that Mesopotamians were able to predict lunar eclipses, they would install a surrogate king to the throne intended to bear the brunt of any attack should it happen. And typically that person who is declared to be king would be someone expendable. And for the few sort of hours or days that the lunar eclipse was sort of in progress, this surrogate king would be treated really, really well, while the actual king masqueraded as just an ordinary citizen. And once this passed, as you might expect, the substitute kings typically disappeared. I wonder why. Probably something to do with poison, we think. But there are other ancient peoples who believed that lunar eclipses, just like in solar eclipses, the moon was indeed being attacked. It was actually being eaten. So what you saw eating the moon in your imagination really depended on your culture. So the Incas saw a jaguar, the ancient Chinese a dragon, in India it was a demon, in parts of Brazil a frog, and to the Nordic cultures a wolf. And the way that you got rid of whatever was attacking the moon was typically to make a lot of noise and fuss. And so the Incas threw spears at the moon, banged drums, as did North Americans. Indians, the people of Maasai, threw sand in the air. Others brought fire out of their huts as an offering. The Romans threw firecrackers at the sky and paraded with lighted torches. Babylonians set up altars and also had their own parades. The Chinese, ancient Chinese, also banged to scare the dragon away. And Hindus beat pots and pans with spoons, apparently. Now today we obviously know what is eating the moon, and that is Earth's shadow. Yes, it was us all along. And that's really a far more exciting story, I think, for many reasons. Because unless you're an astronaut, your experience of Earth is probably a lot like mine. I might go up and down hills and mountains and get on planes. But overall, my experience of being an Earthling is that I'm walking around on a flat planet, you could say. You know, that's my direct experience. And the notion of living on a sphere suspended in space and dancing with other spherical celestial objects is one I can believe. You know, science tells us Earth is round, and then we see photos from beyond Earth. But during a lunar eclipse, what happens is we actually get to see for ourselves the curvature of Earth by its shadow on the moon. We get to see with our own eyes and kind of embody this intellectual knowledge that we have, that we are indeed on a spherical planet. And this, by the way, is what Aristotle discovered by looking at several lunar eclipses over a period of years. If you remember, lunar eclipses are typically more commonly seen than solar eclipses because of the larger shadow. They can be seen in a larger area of the world, so they're a bit easier to track. But it was by noticing the curve of the shadow on the moon that he was able to know that the Earth is not flat. And that was in about 300 BCE. So if you have any flat earther friends, and we all know a few, drag them out today, show them this lunar eclipse and show them our planet. Out today, show them this lunar eclipse and show them our planet's curved shadow. In fact, while you're there, you should really just drag out everyone to see this, because there's something so special about these celestial events that remind us that we're on one planet together. As Carl Sagan says, you know, this is all we've got and we're all we've got. And it's rare we get this perspective of us being whole. You know, we chiefly walk around driven by our own self-interest. But times like lunar eclipse, we really get a different perspective and begin to see our sort of collectiveness really as a planet. And finally, we're not the only ones who are moved by seeing the Earth's shadow. At least I know I'm moved whenever I see Earth's shadow. The Earth itself shudders. Well, this is my interpretation, because in 2010 there was some research carried out to track whether seismic activity increased around lunar eclipses, and it was found that it does. About 2 weeks either side though, so it's not an exact correlation we can hang our hat on. And there has been further research out since. But if we're letting our sort of, analytical minds just drop for a moment, we really can start to think of whether maybe the Earth shudders because she sees she has a shadow side. So there's so much juice to think about with a lunar eclipse, in addition to just sort of letting all the thoughts go and just watching this amazing event take place. And I do hope that you'll share with us over the course of the evening what you're thinking and if you're moved by this particular lunar eclipse. But I will leave you now in the safe hands of Paige and Paul, and wish you a very happy lunar wolf moon eclipse.
We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at slooh.com.
Welcome back. You're joining us here on Slooh tonight for this live event of the 2019 lunar eclipse, and I'm Helen Avery. As we talked about before, this is also known as a wolf moon. It was a name given to this moon by... Welcome back. You're joining us here tonight for this live event of the 2019 lunar eclipse, and I'm Helen Avery. As we talked about before, this is also known as a wolf moon. It was a name given to this moon by Native American peoples of northeast US, and also stretching out over into the lakes. And it's thought that it got this name in January because it was, a period of midwinter. There wasn't much food around, and so it's thought that wolves could be heard howling outside the Indian villages at this time of year, and so it earned it the name the wolf moon. Now, there's a really deep connection between Native American peoples and wolves, and indeed, I had the pleasure of interviewing a gentleman called Carl Goreboy from the Ojibwe peoples several years ago, and he was talking about how the ecliptic is actually known to the Ojibwe people as the wolf trail. It's sort of a wolf tracking around the sky is the ecliptic. And he also mentions in a book called Talking Sky that as the Ojibwe people sort of looked up at the sky every night and could see this sort of pattern of stars making sort of a predictable movement, they also noticed what they thought were some stars moving in different directions. Of course, planets. And they were sometimes... Welcome back. You're joining us here on Slooh tonight for this live event of the 2019 Lunar Eclipse. And I'm Helen Avery. As we talked about before, this is also known as a wolf moon. It was a name given to this moon by Native American peoples of northeast US and also stretching out over into the lakes. And it's thought that it got this name in January because it was, a period of midwinter. There wasn't much food around, and so it's thought that wolves could be heard howling outside the Indian villages at this time of year, and so it earned it the name the wolf moon. Now, there's a really deep connection between Native American peoples and wolves, and indeed, I had the pleasure of interviewing a gentleman called Carl Goreboy from the Ojibwe peoples several years ago, and he was talking about how the ecliptic is actually known to the Ojibwe people as the wolf trail. It's sort of a wolf tracking around the sky is the ecliptic. And he also mentions in a book called Talking Sky that as the Ojibwe people sort of looked up at the sky every night and could see this sort of pattern of stars making sort of a predictable movement, they also noticed what they thought were some stars moving in different directions. Of course, planets. And they were sometimes called the lone wolf. They were considered to be wolves that had left the pack and were making their own kind of trail of their own, if you will. So I thought maybe I would read to you one of the wonderful creation stories from the Ojibwe that talks about man's deep, deep connection to wolf, and then end with a poem. So the story goes that in his travels, original man began to notice that all animals came in pairs and they reproduced, and yet he was alone. He spoke to his grandfather, the creator, and asked, "Why am I alone? Why are there no others like me?" And Gitche Manito answered, "I will send someone to walk, talk, and play with you." So he sent Ma'engan, the wolf. With Ma'engan by his side, original man again spoke to Gitche Manito and said, "I've finished what you asked me to do. I have visited and named all the plants and animals and places of the earth. What would you now have me do?" And Gitche Manito answered original man and Ma'engan, "Each of you are to be brother to the other. Now both of you are to walk the earth and visit all of its places." So original man and Ma'engan walked the earth and came to know all of her. In this journey they became very close to each other. They became like brothers. In their closeness, they realized they were the brothers to all of creation. When they had completed the task Gitche Manito asked them to do, they went once again to the Creator and asked, what should they do now? And the Creator said, "From this day on, you are to separate your paths. You must go your different ways. But what happens to one of you will also happen to the other. Each of you will be feared, respected, and misunderstood by the people that will later join you on the earth." And so it came to pass. Beautiful. Food for thought. And then just finally to end, there's a wonderful book of poems of the Native American moons called 13 Moons on a Turtle's Back by Joseph Bruchac and Jonathan London. And this particular moon that we're looking at tonight isn't just called the wolf moon, it's called the moon when wolves run together. And I thought I would end our time together this evening with this short poem about it. Long ago, an old wolf came to that time when his life on earth could last no longer. My people, he said, you can follow my footsteps when the time comes for you to join me in the skyland. Then he left the earth, climbing higher and higher, and each place he stepped, the sky filled with stars. Skunk, Manitou, Tanka, we call the wolves, the powerful spirits who look like dogs. When they climb the hills to lift their heads and sing towards that road of stars, their songs grow stronger as they join their voices. So in this moon, we climb the hills, lift our eyes towards the wolf trail, and remember that our lives and songs are stronger when we are together. So it's a Lakota Sioux poem for the wolf moon. And I'll leave you with that and these beautiful images of our lunar eclipse. Have a lovely evening.
Hello, I'm Paul Cox, and you are watching Slooh. If you've only just caught up with the show, Slooh is a worldwide community of people learning to explore space together and control the very telescopes that we're watching live streams from tonight. We've got 2 observatories where Slooh members control the telescopes. Our flagship observatory at the Institute of Astrophysics of the Canary Islands, which is about 300 miles off the west coast of Africa, about 8,000 feet up altitude on top of a volcano, home to, do you believe, the largest optical telescope in the world. So those are the main telescopes that you can use, but we've also got our Chile Southern Hemisphere Observatory as well, where you can explore the Southern Hemisphere skies. But anyway, what are we doing tonight? Well, we are watching the lunar eclipse. What are we calling it tonight? It's a supermoon, it's a wolf moon, it's a blood moon, it's a total lunar eclipse. And what you can see here on the screen are some of our live feeds from the Canary Islands. We've got 18 minutes until we reach what's called the total phase, but we can already see here we've got some of this color coming in. And as we go deeper and deeper into the eclipse, that color is going to get richer and richer. Now, we're going to talk a little bit about this later on, but the color that we see the moon turn during a total lunar eclipse can tell us quite a lot about the atmosphere of Earth and how clean it is. Now, in the Industrial Revolution, apparently sometimes they could hardly see an eclipsed moon at all because there was so much smog in the air, so much dust. Other times, I think there was a time in the 50s or maybe the 60s where there was a large volcanic eruption around the time of eclipse. And that made the atmosphere so thick that they didn't see it turn red. It disappeared altogether. So if Earth didn't have an atmosphere at all, actually a total lunar eclipse moon would be totally black. You'd actually see it only because it would be a kind of black silhouette against the starry skies. But that's the other thing that we said at the top of the show. You need to keep your eyes open, because as we adjust all of the exposure on these cameras to deal with the fainter moon, we might start to see background stars popping out as well. And what's great if that happens is that over the course of a few minutes, and certainly over half an hour, you'll see the moon moving against those background stars, which is really, really cool. But anyway, this is definitely turning out to be my favorite feed. Now, you just saw it click there because we're doing some experiments where we've got a whole bunch of different settings that we're using on that particular telescope. So within every 5-minute period, you'll get different exposures coming out in each image feed. So keep an eye out on that because some might be better than others and perfectly judged. Now, if you were watching the beginning of the show, you'll know that I'm not alone tonight. I have a co-host, Slooh's director of a research and education, Dr. Paige Godfrey. And you're wondering where she is. She should be up there in the box above me, but she's not there. And that's because just before we were due to come back on, her hubby said, "You've got to take a look at the moon. It's outside. It looks absolutely fantastic." So Paige just whizzed off to take a look outdoors to see the lunar eclipse with her own eyes. Paige, are you back at all? Yay, Paige, what was
The
it like?
studio
Come
can
on.
bring me on. Yeah, I'm back. Sorry, my cheeks and nose are all red right now. I apologize for stepping away. Paul, thank you so much for taking the seat for a minute. It was like, I don't want to say I'm near tears because that is maybe dramatic, but maybe not. Like, it was just it's beautiful. It's absolutely beautiful. So our skies are super clear. I mean, there's clouds, but like they're moving really fast. There's a lot of stars out. The moon is just this perfect ball. There's a perfect crescent of white in the top corner, and the rest of it is a stunning deep red. I mean, the color is just so perfect, so saturated.
How would you describe that color, Paige?
A very deep red, like blood, actually, maybe darker. Like,
Really?
yeah, it's maroon, I guess. I'm trying to like go through my Crayola color
Wow.
knowledge.
Yeah.
It's a very dark red. Crimson. Maybe it's
Wow.
crimson.
So listen, we've got to make sure that our live streams here are great for everybody who's clouded out themselves tonight, or maybe on the other side of the world in East Asia or Australasia. Anybody down there can't see this in their own backyard because it's daylight
Yeah.
there on the other side of the
Yeah.
world. But Paige, every opportunity you get, you need to make sure you go
Yes.
outside to witness it with your own eyes. And
Absolutely.
anybody also, I know the Slooh crew at HQ in Connecticut are also kind of popping
Yes.
outside in
Yes,
between
please do,
their
studio.
work
Please go outside.
and make sure you don't miss it. But look, here we can see
It's worth the cold.
it's getting really dark here because we're only 13 minutes away from this total phase, which
Yeah.
itself is going to last around 62 minutes. Now,
Yeah.
the color that you were seeing there, Paige, is going to just carry on getting darker and darker and richer and more saturated as the moon gets darker and darker. But you said, and we can see it in our live stream here, you said that there was a definite curve in the
Mhm.
shadow, which kind of takes us on to what we were going to talk about next. What
There
have
we
we
go.
got to say to the flat earthers out there? What is this lunar eclipse going to illustrate so perfectly
Yes.
to put them down and show them that they are very wrong indeed?
That the earth is round. So we're seeing the curve. The moon is moving in Earth's shadow, and we're seeing the shadow overtake the moonlight on the surface of the moon, reflecting to us. And so we're seeing the crescent left over because the Earth is round. And so our shape is being projected into this view. So if you look at the lunar eclipse side view that we have up on the screen, you can see where the moon is actually moving through the phases behind the Earth. And so the shadow, it's moving in the shadow where the sun is on one side projecting light onto the Earth. We happen to be on the night side of the Earth during this eclipse. As Paul mentioned, there's parts of the Earth that are on the day side, and so they can't see this from where they're located. And because the Earth is round, we're seeing the round shadow on the moon.
So I wonder
actually-
what the flat earthers actually say about this. But what interests me about this phenomena of the flat earthers is that what you were just describing there, Paige, It's not something that we've just come up with. It's not something that the Victorian
Right.
scientists came up with. It's not something that came up with in the Enlightenment with those scientists. This was first observed by Aristotle,
hmm
who lived, what, 2,400 years ago. And he was the first person to describe this by seeing quite clearly this curved shadow during a lunar eclipse. And quite
hmm
simply, yeah, it's kind of primary school stuff. We cast shadows. We make bunny shapes with our fingers, and we see a bunny shaped shadow. You know, Please, flat
Right.
earthers out there, go outside, have a look at the moon yourself. You tell us what else is making this curved shadow on the moon. But anyway, I guess we've hit those poor people um, enough page. I do kind of pity them, but anyway, let's go on
If
to
you're
our next one.
curious, you can go to, there's an illuminations post on our website that we'll share on Twitter that we talk about Aristotle and his observations of lunar eclipses and how he repeatedly noticed the curved shape on the moon, which just proved that the Earth was this spherical shape because it never was not round during the lunar eclipses. So you can go read
Yeah,
a quote by Aristotle that was recorded that he wrote in 350 BCE. And so that illuminations post will go out on social.
exactly. And it's a great little post, is it? And a lot of our illumination posts are these lovely little snippets of
hmm
factual knowledge, but some of it's poetry and culture and stuff like that as well. But Paige, we said at the top of the show, we talked about why you described the moon orbiting Earth and
hmm
this alignment, the sun, the Earth in between the sun and the moon. So we know that the moon is passing into Earth's shadow. So why don't we get lunar eclipse every single month when there's a full moon? Why doesn't it always pass into Earth's shadow?
Right. So the way the system, the Earth, Moon, Sun system, so the Earth orbits the sun and the moon orbits the Earth. And so what we're looking at here in this animation is the tilt of the lunar orbit around the Earth. So see how the orbit is tilted. It's on a 5-degree tilt. So what we call the ecliptic is where the plane where the sun and the planets of the solar system lie as they orbit around the sun, this plane, the ecliptic plane. And so, if our moon were to orbit the Earth in this ecliptic plane, then we would have a lunar and a solar eclipse every single time the moon orbited the Earth, because it would either go in between the Earth and the sun, or it would go behind the Earth into the shadow. But because the moon is on this tilted orbit, I'm not sure that my finger is doing the job. You should probably definitely look at the animation instead. But it doesn't always go in between the Earth and the sun and behind into the Earth's shadow based on where the sunlight is pointing. So it will go around the Earth and it will do this configuration, but the sunlight is shining on us on this ecliptic plane, and so the moon doesn't always go in the Earth's shadow. And so what's interesting that I actually just read about today is that because of the tilt, that the solar eclipses and lunar eclipses tend to come in pairs. And so there was just a partial solar eclipse earlier in the month. And
Yep.
that's no coincidence. That's because of the orbit and the way that the tilt makes this phenomena happen, that they tend to come in pairs.
Yeah. And, you know, I'm trying to think. Oh, look at this. This is from the Canary 3 Deep Sky Telescope. We don't usually use this for the moon because it's such a sensitive telescope, a sensitive CCD camera. It's usually kind of blotted out. It's all white. It gets overexposed because Slooh's telescopes are kind of designed to capture really faint objects like
hmm
galaxies and nebula and star clusters and stuff like that. But tonight, because the moon is getting so dark, it's actually coming within the range of this particular telescope. And I'm really excited about this picture because this is a total experiment. I had no idea whether or not this was going to work tonight or not. And in fact, we can see I'm going to have to go in there. We can see it's getting so dark now that maybe I might have to change the settings once again while you're on with Raquel a little bit later. So
Okay.
this is looking great. Oh, look at this. This is the ultra wide
Yeah.
field telescope. To ultra wide field. That's going to disappear altogether unless I change some settings on there. But don't forget that
We're only six
all of the
6.5
telescopes,
minutes from total eclipse.
and all of the telescopes that wow, look at that page. Now, anybody who started off watching the show tonight will know that this is our all-sky camera view. This is a special camera that looks up at 180 degrees of the night sky. You'll know that at the beginning of the show, the sky looked blue. It looked daylight. We certainly didn't see any stars
Yeah.
like this. We can see loads of stars there. We couldn't see any of those. But the moon is getting darker and darker and darker as it slowly encroaches into Earth's shadows, its penumbral shadow and its umbral shadow. So that's really quite striking. Maybe we can also look at the panorama. Wow, Paige, that is how this view normally looks on a moonless night. So
Right.
this is full low light cameras giving us a full panorama of the entire observatory. You can see there's a huge telescope there, which is the optical ground station telescope there. And we're looking down onto the clouds, thankfully, tonight at the observatory. But the time lapses, we will produce and share time lapses from both of those special cameras tomorrow in the Slooh discussion board, because that will look terrific. It'll just look like it's like a lunar month, all within the space of 3.5 hours. That's absolutely brilliant. Anyway, Paige, what else we can talk about next? I'm getting too excited about what we're seeing there. So that was why we don't get a lunar eclipse every month. But
Right.
how about the different phases during tonight's total lunar eclipse? What have we seen already? What are we about to enter in 4 minutes' time? And what have viewers got to look forward to for the remainder of the show?
Yeah. So in about 4.5 minutes, we're entering the umbral phase. So right now we're in the penumbral phase. So if we bring up the lunar eclipse side view image. Oh, this is perfect, actually, the one we're looking at right now. So we're in the penumbra. And so you can see as the moon is moving more and more behind the Earth, the penumbra so the sunlight shines on the Earth, and the Earth bends the light around it. And so some of the shadow that is cast from the Earth is in this large cone shape, and that's the penumbra phase that the moon goes through. And so that's when it starts to just get tinged a little bit. But then you can see right behind the Earth, directly in that skinny cone, is the umbral phase, where the light is completely blocked. And we're starting to enter that in 3.5 minutes. And so what's interesting about the umbral phase is that depending on the distance of the moon to the Earth is how long we're going to last in the umbral phase. So if you notice right here that cone of the umbral phase gets skinnier the further away you are from the Earth. So if you have a mini moon, such as we did over the summer, we had, I think it was the mini buck moon total lunar eclipse. The moon was at its furthest point from the Earth, so it was in the umbral phase for a short period of time. Whereas when the moon is closer to the Earth, such as tonight for the supermoon, it's going to be in the umbral phase for longer, which gives us, we're having about an hour of the umbral phase tonight.
And the other thing that the duration of this total phase is also how central the moon passes through this. If you can imagine a cross section through that cone is circular. Now tonight it's slightly offset, it's slightly north. The moon is passing north, so it's not really going through the widest part of that circle. So they can get up to about 100 minutes long during that total phase. Now tonight, as you say, it's about an hour and 62 minutes. So that's pretty good. And it also affects how deep it goes into that umbral shadow, or how close it gets to the center. Also affects how dark it gets as well, and therefore the color. Now look at this. This is why, Paige, when somebody asked me to describe the color of a total eclipse, we count down to 2 minutes. It's, to me, it's more peachy than red. Now this can be affected by different cameras, different telescopes, whether you're viewing it with your naked eye, and of course we've all said it can be affected by the actual quality of the sky itself.
Right.
But that was an absolutely beautiful image, wasn't
Yeah, and certainly that color is really dependent on where you are. Like I described it earlier as a very, very deep red. But it's cloudy here, and I do live in a light polluted area, so all of that is going to affect the way it looks to you. So
Yes.
you might see a pink moon, a red moon, et cetera. But what's happening here, and this is where the blood moon comes from, the term is this color, because if you're looking at the animation on the screen, so sunlight is hitting the moon's surface and reflecting back off of us. So the moon has what we call an albedo, and that is the amount of light that gets reflected off of the surface of an object. So the moon's light that we see is not coming intrinsically from the moon, it's reflected from the sun. So when a lunar eclipse occurs, the sunlight is going around the Earth. It's going through the Earth's atmosphere where that arrow was just pointing. And then the Earth is bending the light around it to hit the moon. And then the moon's surface is reflecting that light back to us. So if you look at the dispersion in the color, it'll come back up again. I know the video just restarted. Visible light, the light that our eyes can see, is just a small, tiny portion of the electromagnetic spectrum, which is basically the whole spectrum of light that exists. This includes microwaves, X-rays, gamma rays, UV rays. So visible light is this small portion, and this is where we have the colors of the rainbow. And so red represents longer wavelengths, think microwaves and infrared light, and blue or
Timer,
purple.
Timer. Woo!
Oh,
We've just
commences.
entered. Yeah, so this is now the total
Awesome.
phase, the start of this 62 minutes of the total phase of this
Everybody
lunar
snap your
eclipse. And we can
images to
just see there
commemorate the moment.
that last little snippet
Mm-hmm.
of direct light hitting the moon. So we've got 66. So this now,
Beautiful.
that diagram that you showed us just now, Paige, this is the
Uh-huh.
moon fully entering the umbral shadow, that central darker shadow, isn't it?
Yes, right. This is when the moon just entered the umbral phase behind the Earth. So it is officially in Earth's shadow. And this is where we're going to get that deep red color from. So I was talking about the separation in the colors of light in the visible spectrum. So these long red wavelengths, I'll try to keep it short, is what gets through. So the Earth atmosphere scatters away all of the shorter wavelengths of light, and the red long wavelengths are what gets through. So that's what's reflected off the surface, and that's what we're looking at now. That's why the moon is right now.
This is the same phenomena that causes sunsets and sunrises, and it's called the Rayleigh scattering, isn't it? So
Mm-hmm.
this is what you were talking about, that the shorter wavelengths of light, the blues, greens, everything other than the red end, get scattered more easily by the atmosphere. So the only thing that's left, the only light that kind of makes it through, is that longer red wavelength light, and
Mm-hmm.
that's what's hitting the moon now. I love
Yes.
this, Paige. This is a great event. We've been so lucky tonight. You've been lucky with the weather where you are, so you've been able to poke your head out the door. We've been very lucky because the Canary Islands Observatory closed at the beginning of the night because it was covered in. We were actually in the cloud, and I've just heard from Slooh HQ that they've just popped outside in their 4 inches of snow. Not sure whether they're going to be able to leave the office tonight, but they've
Well,
said that
actually, we just
it's looking great.
Yeah. And we just heard from the studio that they got to go outside and see it. They said the red is coming through. So cool. We're also getting some awesome feedback from our viewers on Twitter. Karen Sawyer from YouTube said, Paul and Paige are making this so fun. Thanks for your knowledge and enthusiasm. I can't see it because our sky is totally cloudy and it's snowing.
Oh,
Thanks
no.
again for sharing. Yeah, so this is what we're here for, to share with you. And we have a question from YouTube, which brings us right into the next thing we were going to talk about. The question is from Kyozo9999. I don't know what your real name is. That's your username, but if that's you, hey, thanks for your question. So the question is, I wonder what the view is like from the moon right now, and that's exactly what we were going to talk about. So
it was, and this is one of my favorite things, which I don't actually, on the first few lunar eclipses I watched, Paige, it didn't even cross my mind what an astronaut might see, but they're basically going to see the Earth surrounded by all of the sunsets and all of the sunrises on Earth
mhm.
at the same time, aren't they? Is that what's happening?
So think about the configuration that's happening for us. We are in between the sun and the moon right now. So if you were standing on the moon, the sun is in between. You were standing on the moon, the earth is in between you and the sun. So this is what you would see. You would see a solar eclipse from the lunar surface if you were standing on the moon right now. The configuration is essentially backwards from what we have.
Oh, you're back. You froze again, Paige. That was
I
because
did
you went
freeze again.
outside.
Literally frozen. It is 10 degrees
But
here.
if you were an astronaut standing on the moon's surface now, and it's criminal that no human has set foot on the moon for over 40 years, how we as a species, technological species, can allow that to happen. I'll get off my soapbox again. But anyway, if they looked around at the moon's regolith, all that dust and the rocks and stuff like that, imagine what color that would be. That must be taking on these red or pinkish orange hues, just as they see the Earth atmosphere basically silhouetted, with
Yes.
this orange sunset around the entire globe. It would look absolutely beautiful, wouldn't it?
And you'd see those rainbows like you saw in that animation on the side. You'd see the light spread out from the Earth's atmosphere, just the way we were talking about it. So you'd see all these different colors, and you'd see the reddish orange atmosphere around the sun, the ring of fire. It would be, I mean, we were talking on Friday about like commercial spaceflight trips to the moon to see these events. Why not? Elon Musk could do it. SpaceX, we're coming for you.
Exactly. Yeah. The first person's booked on it, isn't he? I think it's one of the Asian billionaires, isn't it, the fashion mogul, who's meant to be going next year, whenever the timing goes. Paige, what else have we got to discuss in this little segment? Because I'm going to rush off in a second. And
yeah, we're about ready to hop off. So we're going to take a couple minute break. Paul and I are going to hop off, and we're going to leave our feeds up. Don't worry. But when I come back, I'm going to be joined by our guest, Raquel Nuno from UCLA. She is a graduate student and planetary astronomer there. And her research specializes in the lunar surface and the Martian surface as well, and the evolution and surface features. And so we are going to talk a little bit about the eclipse, but also we're going to talk about the China landing of the Chang'e 4 on the far side of the moon. I'm like accustomed to saying dark side, but I hate that. The far side of the moon. So we're going to talk about I know. Yep. So come back for that in just about 10 feeds. And even if it's 10 degrees where you are, I promise you it was so worth it to go outside. Please do. You won't regret it.
And Paige, just before we go,
Yeah.
I think I just saw a quick flash of Arizona. So the Arizona feed might be coming online soon too. We've also got, I don't know if we just pull up our Florida feed, can we? This is from a longtime Slooh member, Stephen Ammon. And he's been... That's his live feed coming in from Florida. Stephen, thank you so much for getting that online for us tonight as well.
Awesome.
Anyway, that rounds it up for this little segment. We're going to take a short break, but don't forget, Paige and Raquel are going to be back on at the top of the hour. So don't go anywhere. Carry on enjoying the live feeds. We've got 23 minutes until we reach the moment of greatest eclipse.
Hi, everyone. Welcome back. We are being joined on this segment by a very special guest, Raquel Nuno, planetary astronomer from UCLA, University of California in Los Angeles. Hi, Raquel. It's nice to have
Hi,
you.
hi, Paige. So nice to see you. And
Some of you might remember if you watch all of our shows that she was on with us just a couple months ago. And so we are very excited to have her back, especially for such an awesome event like this. So, Raquel, I'm super jealous because I am in, as our viewers know, we're in the Northeast. So I'm in New Jersey and headquarters is in Connecticut, and we are battling single digit
oh,
degrees, ice storms. Connecticut has 4 inches of snow under all the ice. You're in California, you're in LA. It's probably gorgeous there, right?
it is gorgeous. I've gotten a week now. If it gets below 70 degrees, I'm cold. So I think it's about 50 something out there, and I'm putting on my parka, my scarf.
I would do anything for 50 degrees right now. But
So
even
glad to be on
despite that, oh, that's awesome. Despite our cold weather, we were able to get outside to see the eclipse. But were you able to go outside and see it tonight?
I did. We're actually filming it right now. My husband and I set up the telescope. Well, not the telescope. The track. We have a sky tracker, and we put the camera on it, so it should be taking pictures. So we had to
Oh, wow.
sit down and we're doing this. So go and watch the footage afterwards.
That's amazing. Oh my goodness. We would love to see that after if you want to share. Our viewers, I'm sure, would love to see your video. That is so
Yeah.
cool. I was able, so my husband took my telescope outside while I'm on the air and was able to get some really great pictures of it. So I'm like, airdrop me them immediately.
Do you have
um,
I see them?
yeah. I'll definitely share them. Like tomorrow or something. I'll post them online and get them out for everybody to see. They did a really great job. I'm very impressed. And
And
so I mean, the pictures look like what's coming through in our feed. So right now we're looking at, we just switched to our Canary 3 Deep Sky Telescope. Look at that color. So is
oh,
this similar to what you saw outside? And what time, like what part of the phase did you go outside for?
so I was just as it was entering the full lunar.
Okay.
There was a little bit still of white, but all of it was mostly red, and then a little bit of the bright white corner. But
Okay. Yeah, that's
this
what I saw too when I went out.
it's just
So
so
this,
strange to see the moon like that. It's
yeah,
stunning. To me, it's breathtaking to see the moon in such a different, I don't know,
yes,
way that we see it every day.
I know. I was surprised too when I ran outside. I was only out there for like a couple minutes, but I didn't like my neighbors weren't all outside, and I was like ready to knock on doors, like, where are you? Why aren't you watching this? And then I remembered it's 11 p.m. here, so they're in
Right.
bed. But yeah, the color is just really fabulous. It's a very, very dark red here. We are in like a light polluted area and we have some clouds tonight. But
Mm,
that deep red that we're seeing on the screen through the Canary 3, it was even deeper here in person.
wow.
It was very incredible. This is probably the best feed for us right now. So I think we want to stay on this for a little bit. We do have our other telescopes up, and if you're watching at slooh.com, you can take images from underneath of the Space Situation Room show, or you could go right to the telescope feeds themselves. And the all sky camera is actually, if we want to pull that up real quick, it's pretty neat because people who started the night off with us saw that in the all sky camera, really, because it's a full moon, we have so much moonlight, it looks like daylight. Like people have asked us, is that the sun? No, it's the moon. It looks like daylight. But right now, it looks almost as if it's a new moon because we don't see it at all. It's super dark. We can see all the stars. But in the very right area, that like pinkish patch, that's where the moon is right now. And it's just because it's eclipsed. So when it
I
comes back, yeah.
noticed when I was a kid, um,
Mhm.
the sky, the stars look so. I'm like, wait, this is weird. Why is it so bright? Is this just my eye being tricked on? No, of course, it's the eclipse. It makes sense. Much less
Right.
moonlight.
Right. It's the best of both worlds. You get a full moon and a new moon kind of all in the same night. So one of the things that I wanted to talk about with you, based on your expertise in the moon and Mars and studying the surface and basically just knowing everything lunar, is I wanted to talk with our viewers about the far side of the moon, the dark side of the moon, moon phases, like basically sort of taking this eclipse. We've talked a little bit about, like me and Paul have talked to them about like how this eclipse happens, what's the difference between a solar and a lunar eclipse, sort of the configuration. But like I was thinking like you and I could just take a deeper dive on like how does the shadows work when we see the different moon phases? Where's the shadow coming from? How does the orbit configuration make these shadows? And the far side of the moon, is it dark? Is it always dark? Like, where's nighttime on the moon? So in the studio, we have a couple animations if we could pull those up to help us explain this. But just from your research and understanding, like what is this far side of the moon? Tell us what the far side of the moon is.
So the far side of the moon is the side of the moon that we never see from Earth. And we used to call it the dark side because we never see it, but it's actually not dark. The dark side of the moon is, well, we don't call it the dark side, it's called the far side.
Right.
Because we know it's for 2 weeks out of the month, out of the lunar cycle, it's actually always in sunlight. So that's so the lunar day lasts about a week, and the lunar night
Wow.
lasts for the 2 weeks. And so the reason why that is the moon is tidally locked to the Earth. So that means that only one side, we only see one side. So it's rotating at the same rotation as the Earth rotates. So you can see that animation. The reason we see the phases is because by us looking at the moon, for example, if looking straight ahead at the moon and you see a full moon, that means that the sun is lighting it behind you. So it's the full face of the moon is being lit by the sun. So
Right.
it's a geometry. So if, for example, if you're standing and you're looking at the straight ahead and you only see the right side being lit, so you know that the sun is to your right. So that's how I like to think. I can tell by looking at the moon, I see, okay, I know that, and if the right side is lit, I know that the sun is the right side of me.
I like that. That is a good way to remember it. And we were showing everyone earlier about the moon being on a tilted orbit around the Earth, which is why we don't have
Right.
eclipses every month. And so that's exactly what you were just saying, that the full moon, the full face is illuminated from the sun, and that's because it's not behind the Earth because of the tilted orbit.
That's right. It's slightly tilted. So let's say that the Earth is here, the moon will be here. So the sun, you can see that the Earth won't obstruct the view of the moon. So. But right now, where the moon is in the orbit where it is perfectly with the Earth, moon, and
Gotcha.
it's the sun,
Yeah.
Earth, moon.
Right. Yes. I've done that a few times tonight. Especially when trying to explain the difference between the lunar and solar eclipse. I am like, okay, wait. Where's the and then I get the fingers out. I've got the post-it and the pen that I'm like, yeah. So we are 1 minute away from the greatest eclipse moment of the night. So just for our viewers, this is basically halfway between the umbral phase. So the moon is moving in Earth's shadow from the sun. The sun is shining on Earth and the moon is moving in the shadow. And we have the penumbral phase, which we started our night off in. And then we move into the umbral phase, which is the direct cone behind the Earth. And so we're about halfway through. We're just 30 seconds away from being halfway through this umbral phase. So it's the greatest eclipse moment where the moon is directly behind the Earth. And so if you are watching and capturing images, in 12 seconds is when you're going to want to take your greatest eclipse image. And then we will start to move out of the umbral shadow. That will be the next part of the night, and then back into the penumbral phase. Here we are, the greatest eclipse moment right now. I'm so glad you're on air with us for this, Raquel. We have a lot of fun with these moments, and so I'm glad you're here to join us.
I
Yeah.
love the movie.
So
You know that this is like my passion.
yeah, we tend to like, whoa, party, it's the moment. Paul and I had one earlier when we entered the total phase. And so now that we've hit the greatest moment, now we're counting down 30 minutes from now, because the umbral phase was about an hour, for when the total eclipse phase, the umbral phase ends, and we'll enter the penumbral phase again. So
Yeah.
now we're going to start losing this full blood moon color. We're going to start seeing the moon creeping back into view, its normal white light view.
What's your favorite part of the eclipse?
My favorite, what?
Part of the eclipse? Oh, what
Ah,
do you think that looks the prettiest?
I mean, I really love the color. So I definitely want to say any part where you can see the blood moon, where you can see the red color. So any part in the umbral phase. But I particularly like when you can still see a little crescent of the white light. So this total portion right here is great, but I really love when we can see the white light starting to come back through a little bit.
Yeah, I think that's my
What's
favorite
your
as
favorite
well.
part?
Just
Yeah.
seeing the con
Yeah, being in between all the phases almost. I think it's like the most dynamic part of the eclipse. So we were talking about, now that we're talking about all this, like, okay, the far side of the moon and the light, the way that it hits the sun, or the way that the sunlight hits the moon. See, I'm doing it again. So I need my sun and I need my moon. Um, the way that the light hits the moon, and we've got daytime, nighttime on the moon. Some of this has been in the news recently because China just landed their Chang'e 4 lander on the far side of the moon, which is the first time this has ever been done. And I know you know a ton about this. So what's like, I mean, it's the coolest thing. We've never done this before. Like, why did we go there, I guess? Why did we land on the far side of the moon?
So there's a couple of reasons why it hasn't been. First, it's hard. So like I said before, we never see the dark side, well, the far side of the moon of the
Right.
Earth. So there's no way to have direct communication. So from a mission perspective, you could see that could be sort of dangerous. If something goes wrong, let the person know that, hey, something's going wrong. But the really cool thing is about this mission is that they also sent a dedicated relay satellite that was at halo orbit. That meant it's kind of like a weird geometry, but the satellite always in direct line of sight to Earth, but also to the far side of the moon. So there was a soft landing, so something that had engines soft landed on the sun, and they had a rover inside, actually roved around, which is cool. But it was able to communicate with this dedicated relay satellite, which then communicated to the Earth. So it was,
Okay.
yeah, it was. That's one of the reasons why we haven't gone to the far side. That's probably one of the biggest reasons, because hard to communicate. It's almost impossible because
Yeah.
we don't have that direct line of sight with the Earth. So this mission
Wow.
went out to study the far side. So the far side of the moon looks very different from the near side. So when we look at the near side of the moon, we see dark patches and also see the light patches. Well, the far side of the moon is mostly made up of these lighter materials, or called the highland material. There's not a lot of volcanic activity that has occurred on the far side of the moon, which has occurred on the near side, which is what those dark volcanic plains we see. And they wanted to study what the mineral composition, what was the temperature of the surface. There's a thermometer on board. And they also brought along with them a biological experiment where they wanted to grow
Yes.
seedlings. You saw that?
Yes.
So they brought along, they had cotton seeds,
Mhm.
and they were able to sprout cotton seeds, which is really, really, I mean, it hadn't been done. I mean, we do it in the station, but never on.
Right.
So it was a really big
Right.
deal. But of course, as soon as it entered lunar night, so it gets really, really, really cold because there's no sunlight on it. It
For 2
died.
weeks.
But that makes
And it's
yes
going to
for
be
the
a
next.
night time for 2 weeks.
That's
Right.
right.
Wow.
But like here on Earth, if you have seedling and it gets close to frost, it dies. So of course, it makes
Right.
that
Right.
that would have died as well. So that's what
Okay.
happened.
So they need some way to keep the temperature stable in order to have the plant continue to grow.
Of
But I
course.
mean, at least it was able to sprout. That's
Yeah, and I think
really
that was
cool.
one of the things they wanted to see. For example, so there's an increased solar radiation on the surface. It's very different space environment than it here, even in space, the International Space Station. So they wanted to see even at that increased radiation, this seedling would grow, and it did. So if we want to ever want to
So
set up
cool.
bases, it's really important to know if we want to explore, become more of a spacefaring species. We need to know if things are going to grow in space or
Right.
beyond the moon, or yeah.
Absolutely. And something that's interesting, we were talking earlier about we're looking at this, what it would look like if you were standing on the moon and you were in what Earth was experiencing as a lunar eclipse. So right now, if you were an astronaut on the moon, what would you see as opposed to what we see?
Oh,
And yeah,
I think. Oh, I'm sorry. You did already answer that question. I'm trying to figure that out.
go ahead. No, I want me
Would
to
it
work there.
be?
Yeah.
Would you see the atmosphere all red? Is that what
Yes.
you would be experiencing all of the
Mhm.
sunrises,
Yeah.
right? Is that
Yep.
what you see?
Exactly.
Okay.
You'd see a solar eclipse.
I would
Yeah,
love
the Earth would move right in front of the sun. You'd see a total solar eclipse because, right, the moon is totally eclipsed in the Earth's shadow. And you'd see, yeah, the sunrise and sunset. You'd see like the perfect red circle around it.
amazing.
Yeah. But
Would you
something
go?
else
Would you
that
go to the moon?
absolutely I would go. Yeah. Would you go?
You know, my answer changes. Before I had kids, I would say yes.
Sure.
But
Right.
now that I have kids, I'm like, I need to raise them into being
Right.
humans, full-grown humans, and then maybe.
Right. Yes. I think I stunned some of my friends and family recently because we were all together at the holidays and they asked me if I would go to Mars because,
Mhm.
the whole thing about going to Mars right now is like, oh, it's probably a one-way trip. And they were like, would you
Yeah.
go? And I was like, absolutely, I would go. And they were like, how dare you? And I was like, well, I would only go if I didn't have anybody on Earth that I loved and cared about and nobody that loved and cared about me. So yeah. The moon, I think I would do though, because it's way safer and way closer.
Way close.
Yeah.
And we've been there before, so
Right. Right. I would try it. But one of the fun things that I was thinking about with this far side of the moon bit is when we say, what would this phenomenon look like if you were standing on the moon? We're assuming that you're standing on the moon on the near side, on the side that does see Earth. So if you were
Mhm.
standing on the far side,
You've
like you
never
wouldn't
seen
even, yeah, you wouldn't even maybe
and
know that Earth
so
existed.
and we know that it's on the opposite side, so it's nighttime for you on the far side right
Right.
now.
Right. And so they wouldn't, yeah. And they like might not even know. I mean, if you, let's say you just like grew up on the moon and never left the far side, you might not even know what you were orbiting. Like you wouldn't have ever
Yeah.
seen Earth.
Isn't that crazy? That's mind-blowing.
Yeah. It's crazy to think with all of the research on like exoplanets and, if life exists out there, that there could be scenarios where there is life that is in a situation like that.
Oh, that's crazy. I never
Yeah.
thought of
There's there's a lot of research about planets around M dwarf stars, and they're really low mass stars, and because of that the planets are close in and tidally locked the way the moon is to us. So if you were a terrestrial on the far side of that planet, you might you would never, yeah.
Like,
It's
what am I
crazy.
orbiting? What is this?
Why is my planet moving? Yeah. It's really interesting. I don't know how we got all the way on this tangent, but I'll take
I love it.
responsibility. um, yeah, so just to, I guess we'll reroute anybody that like maybe just tuned in or something. We are watching the lunar eclipse, despite the fact that I just took us to M dwarfs and planets around other stars. We're 20 minutes away from the total eclipse phase ending. So right now you are still looking at the total eclipse. The moon is in the umbral shadow of the Earth. And in 20 minutes, it's going to start moving out of the umbral shadow. This is our Canary 3, which is telescope, which is why we see the color. It's actually a deep sky telescope. And one of the interesting things about that is it's usually not used for solar system objects, because what you'll see as we exit the total phase is that the moonlight is very oversaturated, very overexposed, because it's for deep sky objects. So those objects are far away and a lot less bright. And so it's a much stronger telescope. So then we have all this really bright moonlight, which just overexposes. So because the moon is in shadow right now, we're able to actually get a great view of it through this telescope because it's underexposed. And we can see all of this surface detail really, really well through this color. So the highlands and the lowlands that you were talking about, Raquel, are really coming out really nicely. Do you have like a favorite surface feature on the moon? Is that a
That's
thing?
an interesting question. I really like there's these two craters that I like. You can't really see one of them. You can see, so it's Copernicus and Eratosthenes. And the reason I really like these is that the way that we crater counting, the way that we date things in our solar system all started from being that one was on top of another one. So that's how we know something is younger, is because it overlays something else. And so those two craters started the technique of studying those two craters that inspired the scientists to use this technique to date things in the solar system. And they're
That's
on the
awesome.
yeah.
Oh, okay. So they're visible right now to us.
The what?
They're visible. They're on the near side.
Yeah, they're on the near.
So can you see like which quadrant would they be in if we're looking at the moon right now?
I'm trying to look. I'm looking at the picture right here. It's kind of very dim for me.
Yeah. Is there in the studio, is there a better view right now? Like a more zoomed in?
Oh no, you can see it. So it's actually the bright all the way on the left side. See that bright crater?
Uh-huh.
So that's Copernicus there.
Oh, cool. Awesome.
And so right next to it, to the right and above it, there's another crater called Eratosthenes. And so it is older. You can see how that bright Copernicus crater has these bright crater rays? Several of those crater rays go into, lay on top of the Eratosthenes crater. And so the idea was, as things get exposed to the space environment, they get darker. So eventually, over time, those rays from Copernicus are going to be just as dark as the ground, because that's the space weathering dust that's often on the moon. So when most of the time, think darker on the moon as they get exposed to more solar wind and space weathering. And eventually they'll disappear. Those crater rays will disappear.
Wow. So we'll
if
have
you
to,
ever look and you see bright crater ray, that means that it's not.
So over what sort of timescales is that?
Oh, well, billions of years.
Okay.
Geologic time. Yeah, geologic time.
Okay. Got it. So we have someone from YouTube. Their username is Cody Monday. I don't like Mondays, but maybe they like Mondays. I don't know. They say they like eclipses because they bring people together. Sun people, moon people, earth people, Mars people, all watching together. And I love that. That's actually what I wished. I wanted to walk around my neighborhood and bang on the doors and be like, "Go look at the moon. Why aren't you outside?" But that made me think when I read that. I want to ask you what. Okay, so you study the lunar surface and the Mars surface
Hmm.
um, in great detail. Now, there's a movie. I don't know why this YouTube um, comment made me think of this, but there's a movie on Netflix and I haven't watched it yet, but it's called Io and it's about how like the Earth is uninhabitable and so we move to Jupiter's moon Io, which is like not a hospitable environment. So I don't totally understand it. I haven't seen the movie yet, but I've heard some buzz on Twitter. But based on all of your research of the lunar surface and Mars surface, um, where would you recommend we try to set up shop? Like, are you a moon camp person, or do you think we should go straight to Mars and biodome it,
I'm
Matt
definitely a
Damon
moon
style?
person. I definitely think that going to the moon first is just the just it makes a lot more sense to me to
Yeah.
test technologies, to just have a launching pad. The moon has an atmosphere, has less gravity, so it's easier to launch from there.
Okay.
So I think that we should go there first, set up shop there, learn how to live not on Earth, at least that's not Earth, and then move on to Mars. But the moon
Gotcha.
has these caves in that would shield us from radiation, from sun radiation. Did you know that there's lunar caves on there?
I did not.
Yeah, so it happens that happened in the past. So there have been used to be volcanic activity on the surface. So we think that there are lava plains, lava tubes underneath the surface. And so what we think happens that sometimes there'll be a meteorite that hits the surface and
Hmm.
it hits underneath in one of these lava tubes. So you have an opening to these lava caves. And we've imaged these from the Lunar Reconnaissance Orbiter camera. They've seen these caves, and it's the perfect place for humans to go and shield themselves from the heat, cold, and from the solar radiation.
That's
So,
so cool.
so that's where I think we should go.
So that's where we need to put the cotton seeds,
Yes,
is underground.
underground, exactly.
Wow. That's really cool. I had no idea.
Yeah.
That's
And
awesome.
also, the other places that we could go, there's these places on the poles of the moon. We call them permanently shadowed regions. So these places have not seen sun for billions of years. So they actually turn out to be one of the coldest places in the whole solar system, even colder than the surface of Pluto. And so we think there's trapped water ice. So it'd be perfect for if
Right.
we need water. Humans, we need water for fuel. We need water for grow food and for us to survive. And so
Right.
there's water there that we can use
I
at the
think
poles.
you've convinced me that I'm team moon instead of team Mars too. Yeah,
Well, I
totally.
guess we should end up going to Mars too, but the moon
Right. Yeah,
should be
yeah,
the
right.
first.
Right. We got to do one first. And maybe this Chang'e lander is the start of another, I don't know, lunar missions. I mean, we haven't gone in decades, and so especially when we haven't put people on in decades. So, I
Yeah,
mean, maybe this is the start of something.
I hope so. I mean, what the
So,
Chinese are doing is an incredible
yeah.
program, and I'd love to see the United States doing the same thing. So hopefully, this is a little competition between the two countries in a good way,
Right.
a good
Right. Healthy
scientific,
competition, exactly.
yes, which is
Exactly.
how we ended up doing in the first place. So
Yeah. Right. Right. We're all for it. Okay, well, we are just about 10 minutes away from the total eclipse phase ending. And so we're going to start to see the moon's white light creeping back in. So, Raquel, I just want to thank you for joining us again. We love having you on with us. You're so fun and your research is so cool. Our viewers love you. And anybody, if you have questions specifically for Raquel, feel free to shout her out on our discussion boards and we'll make sure she gets them and answers them for you. And Raquel, until next time,
yes,
thank you so much for
thank you
joining us.
so much for having me. I love spending time
Absolutely.
with you, Paige.
Thank you. Well, I can't wait until the next time. We are going to just pop to a short break, and then Paul Cox and I will be back on to watch us exit the total eclipse phase into the penumbral phase again. And we're going to talk a little bit about what you can see in the all sky camera tonight. We got a question on YouTube that we want to answer about, like, what are these stars and white dots we're looking at around the moon? And so we'll be back in just a few minutes. See you then. Welcome back. We are currently about 6 minutes away from exiting the total eclipse phase. We're going back into the Penumbra phase soon, and I'm joined again by Paul Cox as we take you through the end of this phase. Hello. Did you
Hey,
get to go
Paige.
outside and see anything, Paul?
Did what?
Did you get to go outside and see anything?
I did get to go outside, and we have, I don't know if you've heard the expression, it might be an English expression, but we have what's called a pea super. Have you heard of that expression?
No.
Right, a pea super is an English fog, right? And it is so thick that it's like pea soup. So I couldn't even see, I don't know,
Oh
3 feet in
no.
front of me, let alone this incredibly dark moon. So just like millions of us who have been watching this, I haven't been able to enjoy it from my own backyard. But thankfully, we've had these live image streams coming in from the Canary Islands Observatory, and I've just been so pleased with this Canary 3 Deep Sky Telescope showing us these color image streams. Because if viewers have been noticing over the last kind of hour, the other telescopes have been kind of quite grainy, quite faint
Yeah.
and stuff like that, even though I was kind of changing them. And it's just because the moon got so faint. And those are all grayscale cameras anyway.
Okay.
But what we can see here already, Paige, we can see that the total eclipse ends in 4 minutes, but we're
Yeah.
already seeing that brightening of
Mhm.
the limb as the moon is getting to the edge of that dark umbral shadow. But anyway, listen, I really enjoyed your interview with Raquel. What was your
Thank you.
highlight from that?
Ah,
Some nice little snippets there.
yeah. Yeah. I mean, she taught me a ton. I didn't know about all the lava tubes that we can actually access on the moon underground, and how like that would be the best place for humans to try to like shield themselves from the extreme temperatures. And that was really
Yeah.
cool. I also
Look those up.
particularly, yeah, yeah, the
So look
Copernicus
those up
crater.
on
And
the internet, and they look so eerie because in that kind of grey regolith,
yeah,
you've got these perfect edges on them, and underneath it's just this inky black, and they look kind of terrifying when you see them in the lunar reconnaissance images and stuff like that. So quite a few of them that we found, but I think it was who was it? I think it was Jeff Bezos who was saying we shouldn't be living, in lava tubes. We need to be building, proper lunar bases and stuff like that. But I agree with Raquel. Make the most of the local resources,
yeah,
and
we need to
there we
start
go.
somewhere.
We've got these lovely underground bunkers shielding us from the sun's
Yeah.
radiation and stuff like that. So anyway, that's really good. We got some questions to
Yes.
answer, Paige. Let me just see if I
Yes.
can pull
So
one
we
up
have
here.
a question from Sean Stevens from YouTube. If we could pull up the all sky camera, the question is what are we looking at? Like, so the moon is eclipsed right now, so you don't really see it, although over on the right side you can see that pinkish hue. That's where the moon is. But like what is around the moon? What are these white dots we're looking at? Are we looking at stars? Are we looking at planets?
Yeah, so top right, the very brightest thing, as you say, we just
Mhm.
see that kind of slightly pink tinge to it.
Mhm.
Above that are the bright stars. It's a constellation of Gemini. That's Pollux and Castor. So kind of
So you
forming
can
that
see the two
bind.
dots are different colors, the blue and the like
It, it,
whitish red. Yeah.
yeah, exactly. They are different temperature stars. They're a
Mhm.
different part of their life cycle. And then underneath that, the kind of one just to the left of your name, that's the bright star Procyon.
Hmm.
But what interests me actually more is not what's around the moon, but it's what's just rising in the east. And anybody who has stayed up, certainly in Europe, to see the lunar eclipse tonight, this is the view that you're going to be getting. And anybody else, if you get up in the hours before dawn, you are going to look east just before sunrise and see this glorious sight of Earth's sister planet, Venus. That's the really bright one to the left. And then just below it, my favorite planet of all time, planet Jupiter, there. But what you can also see is just to the right of that, you can see quite a red star. And
Mhm.
that's actually sometimes mistaken for Mars. And in fact, its name means rival of Mars. It's Antares, and it's the heart of the Scorpion, Scorpius. And you can just see to the right of it kind of 3 stars, and that marks the head of the Scorpion. So Scorpius is returning to pre-dawn skies. So there's always plenty to see in this all sky. You see the Milky Way as well. We see the Big Dipper actually there as well. We call it the plough over here. Let's call it Big Dipper, don't we? But what we're going to publish in the discussion boards tomorrow is what I think is going to be one of the most unique views of this entire lunar eclipse. It's not going to be close-ups of the moon. It's not going to be those beautiful red colours, but it's going to be this view as we started off the night in bright full moon, not only full moon, but super moon, moonlight, lighting up the sky, making it look blue. It looked like daylight when we started off. And then as the moon traverses across the sky, it's getting fainter and fainter and fainter until it gets to this. And then, oh, there we are. We're at the end of the total eclipse phase of this eclipse.
Yeah.
So what we're going to see now is it's going to get brighter and brighter and brighter. Now, it is going to be dawn in an hour and a quarter, I believe. I have to check that. So we're not going to see quite the end of the eclipse, but we should see now the sky brighten quite rapidly as the moon emerges. But let's take a look at the panorama as well, because this is going to be the other one that really gives us a good view. Now, this view, if viewers saw this at the beginning of the show, this was lit up.
It looked
as well.
like daylight.
You could see, you could see all of the domes there. You could see the huge volcano there. Now we can see stars. This is what it looks like on a moonless night. But this is all going to come alive again as well as that moonlight starts reflecting the direct sunlight that's reflecting off it. And we're going to go back to a normal full moon night. So it's going to be quite cool. You're going to get the same thing there on the page. Have you noticed how dark it is outside now?
Yeah, when I got to go outside earlier, and Raquel pointed this out too, because she also went outside actually around probably the same time that I did. She saw the same phase I did. The stars were so much brighter in the sky, and it's cloudy here, so you wouldn't actually really expect that, but the sky was very dark and you could see a bunch of stars. And earlier in the night with the bright full moon, which if you were listening earlier, I said was akin to the sun. Like it was huge and bright. You couldn't see anything.
Now, Paige, you said earlier, and I'm interested to pick this up because one of our members has talked about this as well, but you went out to see it a couple of times, and you said you almost cried about it. And then during the break, I shared with you that during every total solar eclipse I've seen, I have cried. It's just a totally overwhelming feeling that I can't describe to people. Unfortunately, I haven't seen this in person tonight, but you're not alone tonight in that reaction when you saw it, because Carol Botha from South Africa, she's had she's been saying that she's cried every time she's witnessed a lunar eclipse, and that's the main reason that she says why she observes lunar eclipses far from the madding crowd. You know, so these are events. They're so strange. You know, doesn't matter who you are. It doesn't matter whether you're a very spiritual person. It doesn't matter whether you're heartless, cold and heartless like me, or whether or not you're an absolute science nerd. These things, these celestial events, can become quite overwhelming. And I have never been able to pin down what it is that gives me that sense of overwhelming wonder and awe. I guess that's maybe what it is. It's as simple as that.
We have a question from YouTube. So it was a question asking about the dark side, which Raquel clarified is the far side, not the dark side, because the far side does actually get sunlight. It's just the side we don't see. And they asked, I thought it rotated as well, or does it only rotate fast enough to have this side facing Earth always? Someone replied to them, there is no permanent dark side. It all gets lit as the moon rotates around the Earth. So yes, so that's correct, Mark. There is no permanent dark side. The far side of the moon is called the dark side because it's dark to us. We can't see it. That's just a play on words. It's actually just the far side. But to answer the original question, so it does rotate. So it's the tidal locking. It's actually this resonance where the moon orbits the Earth every about 29 and a half days. And it also rotates around itself about every 29 and a half days. And so because those match up, that means that the one side is always facing us. So I'm going to put on teacher mode again and tell you to get out your props. My sun and my earth and my moon. And so if you like pick a side of an object, and if you don't rotate the object but you orbit it, you're going to notice that you would see all the different sides. But if you actually rotate the object as it orbits, you can make it so that the same side always stays locked. So try that at home with your own props, maybe ones that are more spherical in shape.
Yeah.
But yeah.
So it's you're saying its spin on its axis takes the same
Yes.
amount of time as it
Yes.
orbits the Earth.
Yes.
And
So
our
that
moon
means
isn't
that
alone.
its day is equivalent to its year.
Yeah. But our moon isn't alone in that in the solar system. We've
No,
got
yeah.
Mercury is tidally locked to the sun. So the same face of Mercury always faces towards the sun. The other half is in perpetual darkness, unlike our moon, which does actually get some sunlight.
Right.
But also all of the moons of Jupiter as well. Those are all tidally locked to Jupiter because of Jupiter's immense gravitational field. And in fact, they're squeezed and pulled as they orbit as well. So we've got Io, which is the most volcanically active body in the whole solar system because it's being squeezed all the time. But once again, the same face is always towards. Wow, look at this.
Oh my gosh. Look at that from Florida, from Slooh member Stephen Haman. That is a beautiful feed.
That's almost equivalent to what's called the diamond ring effect during a total solar eclipse. Just as that first bit of sunlight bursts from behind the moon, is very similar to that. So thank you, Stephen, so much for providing a feed. Looks like Stephen's actually in Florida. The clouds have cleared because he's been struggling with those all night. We got another question though here, Paige. We've got this is a question from a long-time member Wayne C, and this is in the discussion boards. And he's got a question about colour when he was listening to us earlier. And he said, do the astronauts on the moon, see the blood moon on the space station? So not on the moon. So do the astronauts see a blood moon on the space station or a black moon during a total lunar eclipse? Do you know the answer to that one? Got a rough idea.
So obviously it depends on where the space station is, whether they're going to see it at all. Remember, because half the Earth right now isn't even seeing this because they're on the day side. So the interesting thing here is that the light that's reflected off the moon at this during this eclipse has entered through the Earth's atmosphere first and is bent around the Earth before it reflects, which is why we see this dark red color. But the other interesting thing is that the light that we're seeing enters the Earth's atmosphere once to get to the moon during the eclipse, but then it also enters again to come back to us. So now if you're on the ISS, it hasn't entered the atmosphere that second time. So I would imagine the color would be a little bit different, maybe a little bit less red. Is that sort of what you would be thinking, Paul?
Yeah, I would. And, the thing is, they're within the moon's orbit. So they are seeing it just as we are, anybody. And don't forget, the International Space Station is actually orbiting the Earth really quite quickly. So they have a whole number of days.
I guess,
They're continually in and out of from the sunlit side, daylight side, and night side. But every time they're on the night side, they're going to be seeing basically exactly the same view as we are. But as you say, the one difference is that reflected light hasn't come back through the atmosphere. I doubt whether that makes very much difference to the color. But they're obviously going to have greater clarity because they're not looking through the atmosphere. I mean, it would be interesting, I guess. You could compare our views tonight at 8,000 feet altitude versus some similar instruments and cameras being used at sea level, looking
Right.
through 8,000 feet more
Right.
atmosphere. But
Mhm.
certainly not. They won't see the black. They won't see a black moon. The only time where that could occur, which can't happen as we're currently set up, is if the Earth had no atmosphere, then no light would be refracted around it during this
Right.
eclipse, and the
Right.
moon just would be totally black. But in which case, the ISS would be no different to us on Earth, except we wouldn't be breathing very well. We had no atmosphere.
They would be
But
faring
anyway,
a lot better than us, in fact.
exactly. So a couple of questions there in the discussion boards. There was another nice little one
Okay.
here, actually, that David H. was saying here. I don't know about anyone else here, and maybe it's his Native American ancestry, but I'm looking at these images and I can see a wolf staring back at me. So lots of people can
Ooh.
see different things in the moon. We see the rabbit, we see the old lady. My favorite is
Mhm.
Tyrannosaurus Rex. But maybe David, sketch over one of the images and show us where you
Yeah.
would see
Yeah. Show us where the
the
moon is.
wolf.
Yeah.
Exactly, that would be really good. And he
The
said
moon. I said the moon. The wolf.
I
Yeah.
won't even try and pronounce it Native American, but he's put a term there which basically means thank you, brother.
Yeah. Yeah, I would love to see that. And so that's something too that I kind of like before we wrap up tonight, at the end of each show, we usually ask our viewers to do something like share with us your image or go capture an image based on what we talked about or, what have you. And of course, we're going to ask you to share your images and share your animations of tonight with us, whether it was taken by your own telescopes and camera at home or whether you took it through Slooh or both. Like, totally share those with us. But something else I think I want to ask viewers to share, inspired by my tear-jerking moment and how Paul made me feel better sharing his moments with us. And this wolf too that you see, like share how you feel. Like, how did you feel
Yeah.
tonight? Like, did you go outside? Did you see anything or not? And did that affect, how you felt about it? Were you breathtaking just from even like watching it through your computer screen? Like, I know I am. How did this make you feel? Are you crying like me, Paul, and Carol
Yeah.
are? I would love to hear, how this made everybody feel. That was a cattail. I'm sorry.
Yeah. That's a good one. Chris A, by the way, has already shared in the discussion boards a photo that he snapped just using his cell phone. So it's a bit fuzzy, but it's interesting that even in a fuzzy picture like that, you can still pick out some of the color. We got another question actually here, Paige,
Okay.
which we've got time. It's not like, I mean, it's 6 a.m. here. It's not like I've got
It's
anything
1
else to do.
a.m. here. Bad, Paul and
So
Sammy.
congratulations to all of our viewers who have actually managed to stay on
Yeah.
this late. But this is from YouTube as well, and it's Blue 44653. It's a very strange surname, Blue. Got 44653. But anyway, she is saying, why is the moon red and not any other color? Now we covered this at length, Paige, at the beginning of the show. But anybody who's come in late, maybe the studio
Mhm.
can line up that lovely graphic video that we've got explaining why the moon went red tonight during its total eclipse phase.
Yeah. So what's happening here is that the light from the sun is hitting Earth's atmosphere because Earth is blocking the moon from view. And so the moon is in Earth's shadow. So basically, the sunlight is hitting the Earth, the moon is moving in its shadow. And so the light that we're seeing from the moon has gone. I feel like my video froze again. So there we go. Am I back? I'm back. So, I mean, I can't have my video frozen if I'm going to use my hands. So the light is it hits the atmosphere of the Earth and it bends around the Earth and then hits the moon surface and is reflected back to us. So as this light goes through the Earth's atmosphere, it's scattered very significantly. And most of all the other color of light, the blues, the greens, the yellows, is scattered away because we're talking about visible light here. So the light from the sun is essentially white light. It's all the colors. and all these colors are scattered away because they're shorter wavelengths. And so the long wavelengths are what get through, and that's the red light. And so that's why we see the moon looking red, because the red light is what the long wavelengths is what makes it through all of the dust and gas particles that are in the atmosphere after the scattering.
Now, Paige, what I've just noticed is we've got another hour in the Canary Islands, so we are going to keep the telescopes trained on the moon
Okay.
for that entire hour before dawn. But what I've just noticed already in this all-sky view is just how much whiter and brighter the moon, which is the thing at the top right-hand side, is suddenly getting. And what we're going to see is all of these stars that we can see now are going to basically be extinguished by the biggest light polluter in our sky, which is the moon, because it's dreadful trying to observe faint objects like Slooh members normally do with the telescopes, faint galaxies and nebula and stuff like that, when there's full moonlight, because it basically makes the images very noisy because there's this background sky illumination. But I think within that hour, that's going to be long enough to see the partial eclipse phase end, to see the sky, get really quite blue and return back to how we saw it right at the very beginning of the show. So that's going to be quite an interesting little thing to keep an eye open for. But if we can just go back to some of our live telescope views, maybe the Canary 1 half-meter telescope, and let's go back to the half-meter, because this is Slooh's biggest telescope. It is a half-meter wide diameter mirror, which is 21 inches, and usually the moon is far too bright to be able to image it. But here we can see, Paige, we're coming out of that phase now, where it was almost too dark, but now we're seeing it slowly emerge once again from that umbral shadow, and this is just going to get better and better. And there's that curve that you were talking about earlier to the flat earthers. We can see quite clearly that Earth's shadow is circular. We can see the curve on it, just as Aristotle did 2,300 years ago or something. So,
and that Illuminations post was shared on social. So if you wanted to check out a little blurb about Aristotle's findings on the lunar eclipses and the curved Earth shadow that he saw, you can go onto our Twitter and find that Illuminations post.
What would Aristotle say today if he thought that there were still people on Earth which were arguing it's flat?
He's turning over in his grave.
What's the Greek for idiot?
Okay, and on that note,
come on, let's put our boots on and lay into stuff that why do these people think this stuff? Anyway, these are terrific live feeds coming. So this is Canary 2 wide field, and go to one of my favorite telescopes actually for this phase of the eclipse, this partial eclipse, which is the Slooh Canary 2 ultra wide field. So this gives us an incredibly wide field view, and you'll see how much smaller, there it is, how much smaller the moon appears in this. This is going to be, I think, the telescope that people should watch for the remainder of this partial phase. Because if we go to Canary 3 again now, the one that's been giving us such glorious color image stream, then we can see now that the moon is already getting too bright and is starting to overwhelm that Canary 3 telescope. So let's take a look at that. While the studio are doing that, Paige, we've got some exciting stuff coming up, haven't we, at Slooh?
We do, enough. Yep, we do. So I'm starting, I don't know if any of our viewers followed my Intro to Astro course that I did last year, but yay, thanks, Paul. I'm going to do another one, and it's not going to be the same one. I'm doing a totally different version. So the first class is going to be on January 31st. It's a Thursday at 3:30 p.m. Eastern. So I'm changing the time up. The first time I ran this, I did it late night on Wednesdays, and now I'm going to do it a little bit more during the daytime, still when our telescopes are online, but more during school hours. So if you're a student or a teacher or a parent or whomever that you think, maybe there's a school age kid that is interested in astronomy, this might be a good time for them. So the first class is going to be on I'm calling it a 3-dimensional sky. So how, we look up at the sky and we see all these white dots that tend to seem like they're kind of next to each other, and in fact they're not, right? They're very distant distances. It's 1 a.m. here. They're very far away from one another in that third dimension. So yeah, we're going to explore that a little bit, and like how we can tell that, and how we use constellations to sort of make the night sky kind of seem plainer to us, but in fact it's not a plane, right? It's very 3-dimensional, and so that's what the first episode is going to be about. So
that's going to be fascinating.
Just a little over a week.
That changes with time as well, doesn't it? Because the constellations change with time.
Yeah.
So it's a fascinating subject.
Yeah.
Now, also,
and then also in February, there's another supermoon. So yeah, we'll cover that as well.
Not. Others call it a supermoon, but it's not.
Okay, all right. It's not a supermoon by Paul's definition, but it's a
exactly. There can
full
only
moon
be one supermoon in a year, and tonight's was the largest moon. There it is. That is the largest full moon of 2019. It is not going to get any bigger than that. Don't let anybody else tell you differently to that.
So maybe we'll find a different name for it before the February show. That can be our challenge. Viewers, what would you name a moon? So it's a full moon that is at a close point to Earth. It is not the closest, so it is not the superest moon. It is a superless moon.
I like what you just said. Not the superest moon.
Not the superest.
I think that will do.
Not the
and
superest.
Then the one the following month will be even less superest.
Less superest. Great.
Anyway, listen, we're still getting this lovely live view.
But Canary I think 3. It's time that we wrap up, and we actually got a very nice shout out on YouTube that I think we could wrap out with, and their username is Cody Moon Day. They clarified it's pronounced Moon Day, not Monday. So that explains, because earlier I was like, I don't like Mondays. Does this person like Mondays? Moon Day. I like Moon days. Okay, Cody. So they said, thank you both for doing this and staying up to share all this. And thank you for staying up to watch with us.
Exactly.
All of our viewers that are thanking us, we appreciate you more than you know. So thank you for being with us during this.
I mean, Paige
and if
is
you're
great
not tired,
don't get me wrong, Paige, you are great company, but it would be a bit lonely around here if it was just you and I, wasn't it?
I mean, aside from the few people that we talk to via these chats, it really is just me and you, Paul.
Yeah, it is. It is. Anyway, listen, Paige, I've really enjoyed tonight. I'm so glad that you and a lot of our viewers actually managed to get outside and catch a glimpse of this with their own eyes. Our feeds have been absolutely fabulous. We've been incredibly lucky, to have clear skies. Thank you so much to Stephen Aman for his feed from Florida. Thank you too to Matt Francis, who was trying to set up his feed from the Prescott Observatory in Arizona, but he was clouded, just like so many of us. But what a fabulous evening we've had now. Paige, about 2 and something hours ago, 3 hours ago, you were saying, oh God, this is going to be such a long show. How are we going to manage? Time flies, doesn't it, when you're having fun?
It sure does. I know. It feels like 5 minutes ago we were like getting on the pre-show call, and here we are.
Anyway, listen, I think
I'm ready for breakfast. I'm ready for bed.
Yeah, that wraps it up for us. I don't know about you, but I can never go straight to bed after a show like this. Buzzing too much. So
yeah,
I'm going to go and make another cup of tea and
definitely going to go back outside. So.
Oh yeah, you can still catch some of this. That's why you're so eager to wrap the show.
Oh, you caught me. I don't know. It's anyway, super bittersweet. Like, I definitely want to go outside, but it's also 5 degrees, literally Fahrenheit. Okay. So I don't actually want to go outside.
Go outside for a short period of time. Slooh members, don't forget, you can carry on watching the live feeds in the telescopes for another hour from the Canary Islands. Chile will continue as well. We have got some clouds down there, but we'll keep that open. I think we should also say a few thank yous as well to some of
Yes.
the Slooh crew who are in Slooh HQ in Connecticut tonight in the studio. We've got Jack, we've got Laura, we've got Todd, and we've also got George working remotely
Yeah.
because he couldn't get through the snow. So thank you so much. You've done a marvelous job over there. And Paige, thank you so much to you and to Raquel as well. That was a great
And
interview.
thank you, Paul. It's
So
always
that's
good
it
to
from
share
us.
this time with
We
you.
will see you very soon.
Yeah.
You're going to see Paige. What was the date again? January 31st?
January 31st. Yep. So not this Thursday, but the
Great.
following one. Mhm.
Well, I'll be watching as well. Thank you, everybody, for watching our coverage tonight. It's goodbye from me, Paul Cox, and it's goodbye from
Yeah. It's good night from me.
Bye all.
Bye.